In this video, we take a look at the relationship between hardware, firmware, and the operating system. It's important to understand the relationship between application software, the operating system, and hardware. So if we start at the top of this diagram in the middle, we can see that application software talks to the operating system. The operating system is then responsible for interacting with the hardware, which in turn sends messages back to the operating system, which finally talks back to the application software. To further extend this diagram, you can think of yourself as the user as being at the top of this stack. You interact directly with application software. This talks to your operating system and then to your hardware. Messages get passed back up to the operating system and the application software, and then you see the end result in the form of updates on your monitor or output through your speakers. When a computer first loads up, it looks to ROM for its initial boot up instructions, and this is because ROM is non-volatile. These are contained in a program called the bootstrap, commonly also called the bootstrap loader or simply bootloader. These initial booting up processes are handled by the basic input and output system known as the BIOS. This is commonly referred to as firmware, and it sits between the operating system and the hardware and provides low-level control for devices. We can now add an extra layer to our diagram. We can see here the application software sits at the top, and this is what the user interacts with. This communicates with the operating system, which then communicates with the firmware, which finally interacts with the actual hardware. So that's everything you need to know for the exam. Pause the video and take some notes. So that's everything you need to know from the IGCSE syllabus. But if you want to learn a little bit more and just dig under the scenes of how this actually works, then watch the rest of this video. So what actually happens the moment your computer turns on, right up to the point where you are in your operating system and have control? Well, let's step through and have a look. Well, first of all, we know the only place where instructions can be fetched from initially is the ROM, as this is read-only memory and has the set of initial startup instructions written into it at the manufacturing stage. Nothing exists in RAM at this point, and indeed, as we said earlier, the computer isn't even aware that your hard drive exists. One of the first things your ROM does is run the power on self-test. It checks that all the required components are present and are available. It actually clears anything that may still be in the registers of the CPU. Now, of course, if these are volatile, there would be nothing here, but it's a safety step that's done anyway. It loads the address of the first instruction in the boot program into the program counter. At this point, control is now passed to the bootloader program, also known as the bootstrap, which carries out its own checks on the hardware. It checks for any BIOS on the hard disk or a storage device called a CMOS RAM, and BIOS is something we look at in more detail in a later video. It combines this with the basic BIOS stored on the ROM and then sends this to main memory. This file of information is known as the boot file. The computer is now essentially ready to load up your operating system. Now, the operating system is normally found on the hard disk, but the computer's BIOS can be configured in such a way so it can be changed to check other drives first. This would allow you, for example, to boot a computer which had become corrupt off a USB pen or an optical drive. The operating system itself is now starting to take control. It searches for various other files, for example a config.sys. It tells it how many files can be opened at a time, which device drivers to load. The operating system may look for additional files, for example command.com, which contains additional information about BIOS and various operating system utilities. Eventually, the operating system is now fully booted up and takes control of the computer, the memory, and loading jobs into the processor. This is the point where you're able to take over. Now, this process here is still highly abstracted, and indeed it will be different depending on the actual system you're using. Some of the files, for example, we've referred to on the right, like config.sys and command.com, are typical for a Windows boot-up system, but not necessarily applicable to others. But it gives you an idea of the complex nature of tasks that has to go on when your computer is first powered up before you're able to gain control. Now, earlier in the video, we talked about ROM and we said it was read-only. But there are different types of ROM and they've evolved over time. They all share a couple of things in common. They're non-volatile, and all the data is either completely unchangeable, meaning it's read-only, or it's changeable but requires a special operation to do so. So the earliest version was simply called ROM, read-only memory. The programming of data for the ROM had to be complete when the chip was actually created and manufactured, and it couldn't be reprogrammed or ever rewritten. An evolution of this was then called PROM, or Programmable Read-Only Memory. As the name suggests, this memory was able to be purchased from the manufacturer and then coded once with a special tool known as a programmer. This was known as burning the PROM. This meant that the manufacturer could actually release blank ROMs. A further evolution was erasable programmable read-only memory. Now, these were the first ROMs which could be rewritten many times. However, erasing them required a special tool that emitted a very certain frequency of UV light, and the ROM would actually have to be removed from the device before it could be erased and reprogrammed. Some of the latest evolution of ROMs are the electrical erasable programmable read-only memory. Now, this chip doesn't have to be removed from the computer in order to have its contents rewritten. The entire chip also doesn't need to be completely erased to change a specific portion of it. And also changing the contents does not require any specialist equipment. Now, as we said, for your exam, you should simply think of ROM as being read-only and unchangeable. But it's useful to understand that even in this area of technology, things aren't that simple.